So let's do some problem based upon the last 3 lectures. We discussed in the lecture 3 about the gradient, and we discussed one important thing. Let's say whenever we are having the function which is depending on x and y, that means if you take any point in the xy plane, correspondingly you will be getting fxy. Yes. Now we discussed one important point, that the rate of change of this function depends on the direction in which I am going in the xy plane. So the rate of change of this function, let's say in this direction, is some rate. If I'm going into this direction, then the rate of change of this function would be different. Yes. So if I'm going this direction, then this function would be changing with some different rate. Yes. If I'm going this direction, then you will be getting some different change in the function. That means you will be having some different rate of change of this function. So we defined, or we calculated one equation in the last lecture, that del f by del s is equal to gradient of f dot s cap. And what is this s? So s was the direction in which we are going. Yes. So let's say in this direction, in s vector direction we are going, then the rate of change of this function in this direction is given by gradient of f dot product with s cap. S cap is simply unit vector in s vector direction. Okay, so this is the equation we derived in the last lecture. You might be look back to the lecture 3 if you want to find the proof of this equation. Okay, now I forgot in the last lecture to mention one important terminology. So we discussed about this concept, but this is what we call directional derivative. Directional derivative. Why? Derivative means just the rate of change of this function, and directional means this rate depends on the direction in the xy plane. Okay, so I did not mention about this terminology, directional derivatives, in the last class, but the concept we have discussed. Okay, so now let's solve the question which was asked in GATE 2014, okay, in the ECE exam. So the question is, we have to find the directional derivative of this function f given by this function at point 1 1 in the direction of unit vector at angle pi by 4 with y-axis. Yes, so we have given the direction s cap in which we have to find this directional derivative, because directional derivative means it depends on the direction. So we have to know the direction in which we have to find this derivative. Okay, and this function f we are given. So we just have to put these values in this equation just to get the directional derivative. Okay, so let's first calculate this del f gradient at this point 1 1. Okay, then we will be finding this s cap, which is unit vector. Okay, so let's calculate this gradient of f. So let me go. Okay, so my function is given. So my function f xy is given as xy by root 2 into x plus y. Okay, and del f is given by del y del f x cap plus del y y cap into f. This is simply the scalar function. Okay, now this is my simply, okay, this is f. So I can also write it del f by del x cap plus del f by del y cap. Yes, now let's calculate del f by del x. So when we are calculating this partial derivative del f by del x, we have to keep the by constant. Okay, this is the definition of partial derivative. Okay, so now f is given by x y under root 2 x plus y. Now del f by del x, now just keep the by constant, okay, and just differentiate it. So we can also write it x square by 1 by root 2 under root x square y plus x by square. Yes, now when we will calculate del f by del x and keeping the y constant, we will be having 1 by root 2 2xy plus y square. Yes, so we will be keeping y constant, so y square will be constant and differentiation of x will be 1. Similarly here, differentiation of x square will be 2x, we will be keeping y constant. So this is my del f by del x, and what would be my del f by del y? So del f by del y would be simply, now we will be keeping the x constant now, okay, so x constant. So let's keep the x constant from here and differentiate. So 1 by root 2, while keeping the x constant, x square would be there and differentiation of y would be 1 plus keeping the x constant, differentiation of y square would be 2y. So this is my del f by del y and this is my, so now the gradient of f at would be simply, we will be adding these two terms. So 1 by root 2 and 2x by plus y square. So this is my x cap plus 1 by root 2 x square plus 2x by. Yes, this is my y cap. So this is my del f. Now del f at point 1 because we are asked to get this directional derivative at point 1 so just put the by value of x and y just 1 so we will be getting x 1 by root 2, keep the x and y 1, so we will be getting 2 plus 1 x cap plus 1 by root 2 again 1 plus 2 y cap. Okay, so after further solving 1 by root 2 and this is simply 3. Yes, this is 3, so 3 by root 2 will be out and we will be getting x cap plus y. So this is our delta f at point 1. Yes, now we have to find the s cap. This s cap we have to find. We have find this gradient of f. So s cap is just the unit vector in the direction we want to go, or in the direction we are getting this directional derivative. Okay, so this rate of this change of this function is with respect to s, and this is also the same s in which we are interested to find the directional derivative. Okay, so we are given the direction as direction of the unit vector at an angle of pi by 4 from the y-axis. So the at pi by 4 angle from the y-axis. So this is the pi by 4 axis, and direction is given by the unit vector in this direction. Yes, so this is our s cap. Yes, because this is given as a unit vector and the angle is pi by 4 from the y-axis. This is given in the question. Now this is unit vector, that means this is 1 and this is pi by 4, so this x distance would be 1 by root 2 and y distance also will be 1 by root 2 because this will be 1 cos pi by 4 and cos pi by 4 is equal to simply 1 by under root 2. Yes, so just find the x and y distance and we can also write then this s cap as 1 by root 2 x cap plus 1 by root 2 y cap. Yes, so this is the vector we have written in the form of x cap and y cap. Okay, so this is given that what is the direction, we just have to get the mathematical expression for this direction. Okay, so now we know the gradient of f and I'm sorry, so now we know the gradient of f and the s cap. So we just have to take the dot product of delta f and s cap. So this would be simply delta f, we got 3 by under root 2 x cap plus y cap dot this 1 by root 2 will be out and this would be x cap plus y cap. Yes, so when you are solving the dot product, x cap dot x cap would be 1 and x cap y cap would be simply 0. So the like term will be multiplied and rest of the terms would be 0. So this 1 by root 2 times 3 by root 2 will be out. So this would be 3 by root 2 multiply root 2 and the dot product of x cap plus x y cap dot x cap plus y cap would be simply 1 plus 1. Yes, and this is simply 3. So this is the directional derivative and final answer. Okay, so the answer for this question would be simply 3 answer. So just remember what is being asked in the question. So that is why I emphasis on this fact in the last class, that just understand the terms, because you might be knowing this mathematical equation but you can't decode this question, what is being asked in the question. So we are given the direction. So just remember, when you are calculating the directional derivative simply means the derivative in a particular direction. Okay, because now the derivative or simply the rate of change of this function will be depending on the direction. So we have to know the direction if we want to find the derivative. So that is why we are given the direction and we just have to find this mathematical. Okay, so that's it. Thank you.